Yes, yes. Uh, Good afternoon, everyone. I'm here, your host, Elias Kasule. Today is Wednesday, 26th of April, and we want to catch up from where we left last time. In our previous video that we had, we reflected on solving simultaneous equations, if you remember, and we discussed or we listed the different methods that are used to solve simultaneous equations. So with those equations, we managed to discuss the substitution method, and we said that in our next video, we shall now be discussing the elimination method. Well, before I proceed with the elimination method, there are some questions which I received from my students in the previous video, so I will talk about them now very fast before we proceed because they are pertinent to be used in the next discussion. Well, I listed them down. One, there is a student who talked about distinguishing between variables and coefficients. So he had a challenge to understand or to differentiate between a variable and a coefficient. Well, with this I would say that what we call the variable is that unknown which we're going to solve. And why we are calling it a variable, it can take up any value. At that time when you're starting to solve, you don't know its value. Whereas a coefficient are those constant, the numbers you are seeing on that variable. For example, when I write 3x, when I write 5p, when I write z or 4z, so those numbers you're seeing, so that is to say we have 3, we have 5, we have 4. These become the coefficients. Whereas these ones, x, p, z, whose values are not known, and you'll be finding our variables. Then somebody asked about the variable, is it only x and y? Well, like I've already demonstrated here, the variable can take up any value, and again it can use any symbol. So you'll see different simultaneous equations in which other variables are being used, only that in my example I used x and y. But as we proceed, you are going to see that we can use any of those letters to represent our variables. That doesn't matter. Then somebody asked that where I add x without any coefficient shown, why did I use 1 other than 0? Well, if you look at the equation that we had, I think it was x plus 2y equal to 9. So always when you don't see any number here, it means that the coefficient is 1. Why? Because we know that 1 multiplied by any number is always that number. In other words, if I say 1 times 3, you already know that our answer is going to be 3. So, still x, if multiplied by 1, then our answer is x. So when you write x, it means that the coefficient there is 1. However, if you say that it is 0, then know that 0 times any number is always 0. So that is now why we choose 1 as the coefficient, or whenever you don't see any number being shown on that particular variable, then the coefficient is 1. So that is a very good information that we are going to use in our discussions. So that's why I decided that let me first answer those questions before we proceed to the elimination method. Alright, so let us now go to the elimination method. maybe I will want to talk about something very fast. Some people or some of my colleagues talked about the board. Yes, I'm soon getting a bigger board, but for now the students are in holidays and the board is coming anytime. We can meanwhile proceed with the lessons as the board is coming. Thank you very much for all your comments, please. I'm very happy about them. So we shall modify each day that comes. So abide by what we have for now and we proceed with the lessons. We shall improve each other day. Alright, so now we want to talk about the elimination method. So still I would start with the word eliminate. What do you understand by that word? To eliminate, in the perspective of grammar, it means that you are getting rid of something. When you are eliminating, it means that you don't want to see that anymore. It is going away. You are phasing it out of the plan. So that is how to eliminate. So basically now here, when we are talking about the elimination method, we are looking for a scenario where a variable you've chosen is no longer going to exist. And now this time, we are going to be making it 0. So the only way you're going to make it 0 is by using the technique that if I have a number 6 minus 6, then I expect to get 0. So also when I have minus 6 plus 6, I'll also get what? 0. So this one will help us when we are dealing with our eliminations. So don't forget that again, when you don't see any sign here, or it means that there, that is a positive, and then the other one is a negative. So you can always change that, and if I write the negative first, then the addition next, if I add them together, still I'll be getting 0. So with this, it will still mean that if I have a 6x minus a 6x, again I'll be getting 0. If I have a minus 6x, again added to a 6x, again I'll be getting 0 in that case. So that is the technique that we are going to be applying to help us do the elimination method. So don't forget the equations that we used the last time. I still have them here, so we shall still discuss this for our elimination method. So focus again on the coefficients. Now we know the coefficients, that this is 5, this is 2, this is 1, we've just discussed this is 2. So when we are eliminating, it is good you look at those or a variable which has the same coefficients. So it makes it very easy for us to do the elimination. So in case the coefficients are not the same, again we shall see how do you do your manipulation for you to be able to eliminate in that case. So when I look at these two equations, this is our equation 1, this is our equation 2. Don't forget our variables, we talked about them last time. So our variables are again x and y. So I look at y, the coefficients, it is 2 and 2. I look at x, the coefficient is 5 and 1. So now with the elimination method, then it is better now I eliminate y very fast. So you can see that this is plus, this is plus. So if the signs are the same, then you subtract. So I'll immediately subtract the two equations. So subtract 5x, already we said this is 1, minus 1x, what do you get? 5x minus 1, we shall get what? 4x. Then 2y minus 2y, now you can see that this is being eliminated, and now that will become a 0. is equal to 13 subtract 9. Of course, what we did on the other side, we still do it on the other side. 13 subtract 9 will give us a 4. So with this, you can see that 4x is equal to 4. So we can now find the value of x. So divide by 4 on both sides, and our x is equal to 1. So after we've got x as 1, then you go back and substitute that x as 1 in one of the equations. So you can choose equation 1, you can choose equation 2, it's up to you. So if I choose equation 1, so 5 times x, so that will be 5 times 1 plus 2y will give us 13. So 5 times 1 is a 5, so we have 5 plus 2y is equal to 13. Then we shall subtract off this on the other side. So we have 2y is equal to 13 minus 5. So 13 minus 5 will give us 8 is equal to 2y. So again, we divide by 2, we divide by 2, and our y will be equal to 4. So we conclude that therefore, I'll use again the blue. I told you that that's a mathematical symbol last time that we used to indicate our therefore. So therefore, those are the 3 dots. Our x is equal to 1 and our y is equal to 4. So these are values which satisfy these equations. So if you check, if x is 1, 5 times 1 will give us 5. If y is 4, 4 times 2 is 8. And 5 plus 8 will give us 13. If you check the second equation, x is 1, that will be a 1. Y is 4, 2 times 4 is 8. And when I add 1 plus 8, I'll get 9. So that one is what we call the elimination method. Thank you very much.